Hey guys, I'm Mr. Sal. We're going to look at a quick lesson on rotations, just some basic properties of rotations and kind of what they look like and how to do them if we're going to do them by hand. So thanks for watching. Don't forget to like, comment, and subscribe. All right, we'll read these while you guys finish up writing these objectives. I can rotate a figure any number of degrees and around any center of rotation. I know that rotations do not change angles, length, or size. Actually, we're not going to focus on the any number of degrees thing. Just means you get to choose how far we're going to be rotating in this lesson. But eventually we're going to have you guys rotate a very specific number of degrees. And again, this is to prepare you guys for the 9th grade stuff, which they're going to go real deep into all of this kind of thing. Alright, so let's consider the types of transformations that we've gone over. Transformations, the first kind that we went over in the first couple lessons. Well, we actually covered all 3 of them in the first lesson, but the first one we went over in detail was translations. The second one is what we just completed, were reflections. And now in this lesson, as we can see in the objectives, we're going to be looking at rotations. Now the thing with rotations, and we can see from this second objective, is that they do not change angles, length, or size, just like the translations and reflections do not change angles, length, or size. So these 3 types of transformations, we do have a specific name for these types, which do not change angles, length, or size. These are called rigid motions. So rigid motions do not change angles, length, or size. It means that the shape is rigid, means it will never, expand or contract. Some people may say that these are rigid transformations, and that works as well. It also means that corresponding image and pre-images are congruent, and this is the symbol for congruence. We're going to see that a lot later on in a different lesson, but I'm just kind of going to introduce it right here. All right, now I'm not going to read that because, again, it can be a little confusing. However, what we want you to do is just take a moment, and you're going to rotate the point P here at the top, right there, around this point O. But what we want you to do is rotate in the positive direction. Now, you may not know what that is, but think about what you think it is and try doing that. And then we'll go over it together as a class. Do it with your partner. Go. All right, up here in the top right, I've got the positive, just so I know that I'm rotating this one in the positive direction. Let's see if we can do this right. So I got this point O and this point P, right? Now, it needs to stay the same distance from O. We're not changing how far away it is. We're just going to rotate it directly around O in the positive direction. So let's go ahead and start rotating this in the positive direction. There we go. That positive isn't supposed to be there. Is that too fast? All right, so if I go back to P, I'm going to rotate this in the positive direction, which is, this is the positive direction. Now, the question is, how would you guys describe this direction?
Rotation.
It is a rotation, but how would you describe its rotation? That's very good. Counterclockwise would be more accurate than to say, well, not more accurate, but it's more technical than saying to the left. So we could say this has been rotated to the left, or we could say that it's been rotated counterclockwise, all right? Where do you guys want me to stop this thing?
Right there.
Like right there?
Yeah.
All right, I'll see if I can do it. Something else we need to consider on this one is that OP was some kind of vector, so we do want to draw this vector right here. Also, we should label this as P prime. Now, it may help also to show again the direction of the rotation, which in this case was counterclockwise. Alright, this one we want to rotate in the negative direction, okay? So take a moment with your partner and see if you can do that. Now let's take a look at this. Alright, so here's what you're going to do with that extra piece of scratch paper. Is you're going to put it directly over this line, which is on the original worksheet that you have. And you're just going to trace it just like I've done right here. Alright? So take a moment and do that. Again, you're putting the scratch paper over this, and then you're just going to trace it like I have. You don't have to do it in red, of course, but trace it, and then this will help us to rotate it. Alright, so if you've done that, you should be able to take the shape and, move it around, right? Now again, we do want it directly on top of this thing so that we can rotate it. So what you're going to do now is you're going to take your pen or pencil and you're going to kind of stick it into this point right here, not like through the paper. But this is going to allow you to rotate it around this point O. Now this one we are rotating in the negative direction, so we should be careful with the direction. It's just the opposite of the way that we rotated the last one. So let's go ahead and see if we can do this. Alright, so the rotation, again, if you had stuck your pen into that point O, you should be able to rotate it just like this. Alright? Now you get to choose where you want to stop the rotation.
On the left of the beam.
I'm going to stop right there. Now you could have stopped where you wanted to, but again, you should have something that looks like this. Even though the original vector OP may not be as visible as what I have right here. Okay, but you should be able to see the rotation that we've done from that. The thing that we need to do is label the points accordingly. So this would be B prime. Again, we'll show this rotation right here, and that was in the negative direction. How would you guys describe this rotation? Yeah, last one was counterclockwise, so this one is clockwise. Now we talked about these already, but just go in with your partner and write a sentence. This first one was the positive direction, and then this one is the negative direction. Write down which direction the point P rotated when we rotated in the positive direction, and then for which direction did the point P rotate when we rotated it in the negative direction. Let L be a line, vector AB be a ray, or ray AB. CD is a segment, and angle EFG is an angle as shown. Let there be a rotation of D degrees around the point. Find the images of all figures when D is greater than 0. So we're rotating these in the positive direction around this point O right here, okay? So take a moment and see if you can do that with your partner. I'll give you guys a few minutes to do that. Again, I recommend you use the piece of scratch paper that you have as a transparency to rotate these. What happens to the O when we rotate this thing, you guys?
Nothing.
It is going to stay. Because when you rotate the center around the center, it just stays the same. Like you could say, well, it turned, it just doesn't move anywhere. And yeah, that would be true. Alright, I'm going to rotate this. Again, this would be in the positive direction. I don't know. I'm going to rotate it about that far. We'll say about that far. Now, if you guys are using the scratch piece of paper correctly, you should be able to see the figures behind it. So hopefully it looks something like this. So what we see in red right here would be the rotated figures of AB, the line L in black, the angle EFG, and then the line segment DC. Again, notice O is still O prime, but it's in the same position right here. And we did label all the images with the prime mark, including the line. We wanted the line. By the way, yeah, so we understand that we put this line here in black, line L. And since we're used to seeing that as a line of reflection, some people, especially right now, may want to reflect the stuff over that line. But we're just looking at rotating right now. Here's our next question. I'm going to show these a little bit differently, but I want you guys to try to rotate these. These ones are going to be in the negative direction though. So down here where it says D is less than 0, it just means that we want it in the negative direction. Take a moment, do that with your partner. Rotate line segment AB and this angle CDE around this point O. So on this one, I'm going to rotate A and B a little bit differently than perhaps what we are used to. So what I'm going to do is I'm going to take a line and connect O and A right here. We'll use a different color. Now what I can do from here is rotate this line just as far as I want to. And again, we're doing this in the negative direction, so let's go and do that. Alright, so I rotated it about that far. Now what I want to do is show the line again that connects O and A right here. The reason I'm doing this is because it shows me the angle that I did rotate A. So this new point at the end of that line is now A prime. So what this means is I can take these two lines that create this angle right here, and I'm going to do the same thing to B. I'm going to duplicate that same angle with B, all right? All right, so I have duplicated this angle over here with B right there. What this means is that this angle that we're rotating B is the same as A, and at the end of that line here is B prime. All I've got to do now is connect A prime and B prime with the line. And this shows the rotation of A and B, however many degrees that is. We just chose that randomly, or stopped it randomly. So purple here is B prime, and then the red point is A prime. But again, I've duplicated that angle. We don't really expect you to memorize this right now. However, as far as I remember, in 9th grade, this is pretty much the way they do a lot of that stuff, okay? So be very careful. But we do have the angle CD and E, angle CDE, and we're going to rotate it around the point O. So again, I'm just tracing over it. If I had a scratch piece of paper to put over it, I've traced it, and I've got to identify my point O up here. And we're going to rotate that around point O in the negative direction. Here we go. All right, this should do it. There we go. Now this is the negative direction here, clockwise. And, well, we could go anywhere we want. We'll make it so we can see it though. I'm going to stop it right there. See if I can stop it. All right, we'll just do this one since the technology is not working on this. Keep in mind as well though that you do need to label this one C prime, D prime, and E prime. But what we should also do is acknowledge this 45-degree angle, which means that this angle is still 45 degrees. Now this one was rotated a little bit more than the way that we had it, but it still works, okay? Because we got to choose how far we rotated it. And again, this is in the negative direction, so it should be clockwise. So the rotated segment A prime, B prime, this one would be 4 units. Because this one was also 4 units. So what is the length of the segment that was rotated AB? Let line L1 and line L2 be parallel lines. Let there be a rotation by D degrees, just some number of degrees, all right? Ignore the inequality right here. About point O, so we are rotating it about this point. And after we do the rotation, we'll answer this question: is line L1 prime parallel to line L2 prime? Take a moment and rotate these two. Some number of degrees, you get to choose. All right, after the rotation, this is what I got right here. Now again, the next question is, these two red lines that we have drawn, are those parallel? Well, yeah. So we started with parallel lines. Even after the rotation, they're still parallel. So the answer to this one is yes. All right, let line L be a line and O be the center of rotation. We're going to rotate line L where D is not 180 degrees. Okay, just rotate it so it's not 180 degrees. And then we need to figure out if the two lines are parallel. All right, let's see if we can rotate this line. All right. This didn't say which direction, so we could rotate it this way if we wanted to, or we could rotate it this way. You get to choose on this one. Well, what the heck? I guess this will work. So this line, is it parallel to line L?
No.
No, it is not.
Perpendicular.
So, well, we could try to make them perpendicular or something like this, looks like. But it's not necessary that they be perpendicular. We just need to know if they're parallel or not. And they are not. Now, if I did rotate it 180 degrees, would they be parallel? Yeah, now they are parallel, okay? But if we don't rotate it 180, automatic, not parallel. All right, so there's our objectives for this lesson. Again, we need to be able to rotate any number of degrees around any center of rotation. We're just using some kind of transparency or scratch piece paper to do that. And then we need to know that rotations do not change angles, length, or size, which was demonstrated in a couple of those examples. All right, take a moment with your partner then and see if you can do these problem set questions. There's several of them. Rotate these, all three of these around point O, negative 90 degrees. All right, this rule right here with the AB and the negative AB stuff, this stuff, we're going to be using that at least a little bit today. And if we can remember this objective, hopefully we'll see a lot of these rotations are going to be fairly simple, especially when they do give us a grid to work with. This one is just a picture of an angle that was rotated. The angle right here is this one right here. And it was rotated around to give us this angle right here. But there's a couple things we should notice about these, at least if I had copied them right, is that angle M is the same as angle N. Also, L2, line L2 is kind of one line right here. And then line L1 also, this is kind of like one line right there. All right? In this example, we kind of got this red shape that we start with right here. And it has been rotated 180 degrees. One question we should address on this, though, is the 180 degree rotation, was it rotated in the positive or negative direction? Take a minute, 1 minute, talk about that with your partner. What do you guys think?
Positive.
Positive. So you guys are saying it was rotated this way?
Yeah.
Do you guys think it was rotated negative?
No.
It
could be either.
Very good. It does not matter. 180 degree rotation will put it in the same position whether you do it in the positive or negative direction. Alright, on this grid it gives us this point down here. this one. And that, the coordinates for that point are 2, -4. We're going to rotate this point in red 180 degrees around the point here in the origin. 180 degrees. Do that with your partner. I would recommend using the paper to do it. Let's go and rotate these. The red point around the purple one. I'm trying to keep that on that center of rotation right there the best I can. Let's see if I can do this a little bit better. Alright. There we go. Oh no, that didn't work at all. There we go. Alright, I'm rotating. Oh man, it's supposed to stay still. Sometimes technology stinks, I guess. Yeah, too far, right? So we should get this point right there. Alright, and this would then be the coordinates of this one are -2 and +4. Where the two original coordinates were 2 and -4. So we need to compare these two. What do you guys notice about the ordered pair in red and the ordered pair in green? That's very good. So we notice that the 2 here became negative up there, and the 4, which was negative, is now positive. So we just switched the signs on the 2 and 4, and that gave us the new coordinates for the rotated 180 degrees pre-image. We're going to have you guys rotate the point -3, 5, 180 degrees about around the origin. Alright, let's rotate that red point 180 degrees. This one works a little bit better. Bam, there it is, 180 degrees for us. Right there. And the coordinates of this point would be 3, -5. So what we really want you guys to do now is to draw a line from the new image point to the pre-image point. Okay, try to use a straight edge for this because it'll make it a little bit more clear what the heck is going on with this. Alright, you guys should have something like this.
Oh, real cool.
What do you notice about this line?
It's parallel. Straight.
It's very straight, thank you, but the computer did it. Yeah, it's going through the origin, which is also the center of rotation, alright? What this means is that for all 180 degree rotations, connecting the point from the image and the pre-image will always go through the center of rotation. And I'm going to emphasize this line for you guys. It's right here on your paper. It goes to the point -6, 6, which would be this point right here. What we want you to do is rotate this line around the origin 180 degrees. Take 1 minute and do that with your partner. Let's go and rotate this 180 degrees. So I'm just taking the same line, rotating 180 degrees.
Oh my gosh.
Now this gives us the point at 6, -6, and also the line on that line y equals -6. So this is what we should have after rotating that 180 degrees around the origin. Alright, let L be the line passing through the point 7, 0, parallel to the y-axis. So we can show this line, again, it's just for emphasis. It's this purple line right here. Rotate the line 180 degrees around the origin and see what you get on that. Yeah, so we're looking at this point 7, 0 is this point. Alright, let's rotate it 180 degrees. So I'm just going to take it and turn it. Now again, don't forget, if we had done it the other direction, this way, it would have given us the same line right here. Now that's a little off because of the way this was done, but hopefully there's a little bit more on the line. But this is about what we should get right here after rotating 180 degrees.
That's so hard.
I don't know if it'll stay. We're going to rotate this line L around the origin again. See if you can do that with your partner. And I'm just going to rotate this 180 degrees.
Oh my gosh.
There we go, right there is good. So this line would represent the 180 degrees rotation. But also, we just took that 0.02 and we took the opposites of those, so we got 0, -2 now at that green point. Now this one has an extra question. Is L parallel to the rotation L prime?
Yes.
Yes, it is.
Yay.
Those would be parallel. All right, take the line that passes through 40. Looks like that should be -40. We'll make it negative. All right, rotate this line, L, which goes through the point -40. And rotate it 180 degrees around the origin. And then answer the question, is L parallel to the rotation L prime? Let's go and rotate this 180 degrees. We go in the opposite direction this time.
Swing it.
So we get this point right here. See, there it goes, I told you. Alright, so we got this point. Again, -40 is now +40. And the line is just rotated to this new line right here. Okay. All right, take 1 minute and rotate this line L around the origin, and then answer the question, is L parallel to the rotation L prime? Take a moment and rotate this 180 degrees. Yeah, about right there is good. And this one is parallel. So there we go. Now take a moment and rotate this line L around the origin to create L prime. This one is slanted though, so be careful with how you do this. I recommend using the scratch piece of paper to use as a transparency to rotate this one. So some of you guys are doing this as a reflection and not a rotation. If we rotate this thing, we should get something like this here, okay?
I did that.
So this would be the actual line from the rotation of 180 degrees. So what that means is, what I meant by that is some of you guys were writing this line. That's a reflection. But we're not doing a reflection right now, we're rotating it. So be very careful on those. So just take a moment with your partner and rotate this line L around point O, 180 degrees. This one just doesn't have a grid, but we should still be able to do it. So for this one, what I'm going to do is I'm going to make 2 points on this line. So I'm going to do this one a little different, and I'm going to rotate it around the point O. Now it wouldn't matter where you put those 2 points. Just remember after you rotate it, you're going to have to draw a line through those 2 points. And it just depends on how you want to do it with the scratch paper that you're using as a transparency. Alright, let's rotate this 180 degrees, which would be something like this. And then we should be able to draw a line through those points, if I can get them to stay still.
Yay.
I did it. So this would be L prime. The next question is L parallel to L prime?
Yes.
Yes, it is.